I don't know. Yeah, I'm working on it. I supplement. I don't know. Yeah, cross working. Literally. Oh yeah. Judah, you're still alive. He's alive? Chase. It's been a long time since I don't
Gabby, can you hear us?
Yep. Can you hear me?
Yeah. Sweet. All right, let me try to full screen this.
What I'm imagining now, I look like the face of God.
Pardon me?
I now look like the face of God. I'm like,
Yeah. You're on 4 screens, all facing with you. Sweet. So I guess
I think if you hover on the bottom.
I guess we can stop. Cool. So I guess we can start. First of all, thank you for coming out. It was great. It's great having you here. We have a few people here from different groups, from the workshop, from staff faculty, basically from all over the place, I think, from the math faculty as well. So thank you for coming out and spending time with us. So how I thought of doing this is maybe first few minutes, I'll ask you a few questions that I gathered from the students, and then we'll just open it up to questions in general.
okay, that's good.
Sweet. So the first thing I wanted to ask you about was you had an in-depth article with Hysonomics recently, and in that you talked about how the field of data science existing as a field was sort of a shame to the field of statistics as a whole, because sort of academic statisticians had pushed the whole data cleaning, data munging aspect to other people. So do you still feel that this is the case, and where do you see academic statistics going in the future? With all this big data stuff, do you see it combining more with sort of computer science aspects?
Yeah, absolutely. I still totally believe that. And it sort of always mystified me a bit. And just like when you actually go and do statistics, the problems you face are not often the ones that kind of traditional statistical research equips you to solve. Like often by the time you get to fitting a model, like you've done all the hard stuff. Let alone kind of figuring out the right model, which even I think statistics does not give a lot of guidance on. I mean, so much of statistical theory kind of like assumes, given that you have the right model, all of these properties are true. But in reality, you never have the right model. And just getting to the point where you can model your data is a lot of struggle. And so, during my PhD, I did a consulting assistantship. So I helped PhD students from other departments do their, help them with their research. And, typically the statistical questions were like, some of them were kind of more than incredibly easy. Some of them were, required a little bit of thought, but even in those cases where you had to like think about the statistics a bit, that still ended up like of my time spent helping someone else. That was like 10% of the time was thinking about the statistical model, and the other was, a lot of it was just wrestling the data into the right form where you could analyze it, or then creating graphics so you could make sure that kind of your understanding of the data capture process matched what actually happened. And a lot of the time, I think one of the things that I enjoyed about that is you'd sort of come up with a graph and you'd show the client and say, well, look, something's there's a whole lot of missing data here, and then they'd say, oh yeah, that year there was a bear in that field. A bear in that field, and they they couldn't collect the data. So that I think is really valuable, like that part of the process where you have to build up your understanding, you have to cross-check it with the people who actually know about the data. Like that's really important too. And again, like traditional statistics research, which is all about proving stuff mathematically, gives you no tools to help with that struggle.
So do you think that in the future, a master's or a PhD program in statistics will have to have a heavy computational aspect to it, or do you think that there would still be two fields, one more academic than the other?
I don't know. I really hope that statistics changes so that if you do get a PhD or a master's in statistics, that does mean, you've been forced at least at a rudimentary level to fight with this stuff. In the same way, people get PhDs in statistics and masters in statistics for lots of different reasons, to do lots of different things. And I'm not claiming that every statistics PhD graduate should be an expert data analyst or data wrangler, but absolutely some of it, you have to be forced to do some of it in the same way that, I feel this in the same way that I was forced to do measure theory. Mathematically inclined people should be forced to do data mudging, just so they at least know it exists and they know it's a hard problem and that people are working on it. I think if that doesn't happen, statistics will just have effectively become irrelevant because it just keeps solving problems that people, by and large don't have.
Awesome. The second question I had was your role at our studio. We know about the Hadleyverse, we know about all these packages that you're pushing out. A lot of the students, we're primarily using your packages and a few other augmented packages that are based on yours. But you moved from doing that sort of in your university position to now doing it, I think, full time at our studio. But maybe describe your role as a Cheif Scientist and what that really entails at our studio.
So, basically, I think of my job is to make, I kind of originally, I tweeted this a while ago, that my job is to make R more awesome. But I kind of realized that's not exactly my job. My job is to kind of make you all more awesome through your use of R. Because it's not just making cool new R packages, it's also helping you use the existing R packages and use the new packages as most effectively as possible. So, my mission really is to make data analysis as easy and as efficient and as fun as humanly possible. And, that's what I spend 95% of my time doing at our studio. And that's, basically a sort of a mixture of like programming, of thinking about stuff, which I kind of think of as research, and then teaching people, whether that's an in-person course or, events like this, or writing books about things. So that sort of, it's like programming, research, and teaching is what I do all day.
Cool. The third and final question that the students I think had was also about the tools that are being created to address big data, Apache Spark, Hadoop, and tools, and the integration with R is becoming also an important aspect. Now, from your perspective, do you think all these tools is just hype, or do you think there is a valid reason for learning all of them?
I certainly don't think you want to use all of them. I think we're at sort of a period where these things are really being hyped up because they're new and they allow people to do things they couldn't do before, and people are raising lots of money to do them, and it's really exciting. But I think most of this stuff should kind of be like super boring infrastructure-y stuff. Like in the same way, like no one gets excited about using Postgres to do their data, to put their data in a database. I think in 5 or 10 years time, people are not going to be excited about Spark or Hadoop or whatever. It's just going to be a tool you use to make sense of your data. And because of the sort of, the hype cycle, it does make it very difficult to evaluate new technologies, like whether they are actually, a lot better than what came before. So I don't know. I think it's worth being like sort of cynical and skeptical about stuff that's heavily hyped. But on the other hand, it's also worthwhile sort of being a little tactical and just having, learning and using about using these technologies, just so you can have that bullet point on your CV. And so then you can say, well, I know how to use Spark, and everyone's like, wow, that's amazing. We'll hire you and pay you hundreds of thousands of dollars a year. But, I think in the long term, what you need to focus on is making yourself kind of as, from my perspective, what you should be interested in is how can you become kind of the best data scientist or best analyst you possibly can be. And some of that's, specific tools and programming languages, but a lot of it is just sort of having more general tools in your toolkit about like how can you attack new problems, how can you learn new technologies as rapidly as possible, how can you like figure out what is the next thing that you should be learning, and not to become kind of too I kind of want to say, like, don't become too passionate about your tools, but on the other hand, you shouldn't be like not passionate enough, because you do need to have some passion and for some love for what you're doing, but you don't want it to be sort of an irrational love. You don't want to get to the point where like you feel that your way is so much better that you have a moral obligation to tell everyone else how much better your way is and how bad their way is. That sort of like, as soon as you become like, you don't want to become too evangelical, right? You don't want to ever accept that there's like one truth or one right way of doing things, and that, you understand what that truth is. Because people like that just tend to be really, really, really annoying. I think the people personally who most annoy me are the people I call like evangelical Bayesians. So these are like the Bayesians who tell you that like there's only one like actually logical and verifiably correct way to think about statistics, and that's through Bayes. I don't know. I'm just, personality-wise, I'm just a total pragmatist. I think you want to use whatever works for you, and you should never feel shame for using whatever tools you use. If it gets the job done, you're succeeding. But at the same time, you always want to be trying to do better and trying to find easier and better ways of doing what you already do.
So, related to the big data tools, you've recently been talking in interviews about how a lot of big data problems are just small data problems. I mean, could you maybe explain a little bit about what you're trying to convey there?
So one of the things that I think is kind of particularly frustrating to me about the big data hype is people are like super excited about big data, and yet no one really knows what big data is. And some people think, well, I've got like 20,000 observations, that's got to be big data. So I think it's useful to remember that if the data fits in memory on your laptop, it's small data these days. So if you've got 4 gigabytes of data or 8 gigabytes of data, I think that's solidly small data. But small data, that's in relative terms, 4 gigabytes of data is really small compared to the largest size data that people are working with today. But in absolute terms, 4 gigabytes of data is still a lot of data. And there are a huge number of questions you can answer with that much data without ever having to use big data. So I think in many ways it's like totally fine to specialize in small data. Now, small data is still pretty big, right? It's still gigabytes of data. That still poses some, decent computational challenges. But not everything has to be big data. I think, though, in many scenarios, like, I kind of think of big data as typically like a problem that like a company has. Like all of the data that a company has is likely to be big. But to answer a specific question, it's quite unusual to use all of the data that the company has, and often, through some, often fairly simple subsetting or subsampling or summarizing, you can get that big data down to small data that still, is absolutely can answer the question you're interested in.
I think we can open it up to questions from the audience. So if you have a question, put your hands up and we'll get to you. Yes, Judith.
I remember on one of your articles the interviews that you did with Priceonomics, right? You mentioned something about being particularly sensitive to frustration and how that kind of helps you when you're developing your packages, right?
Yeah.
I'm wondering, is that still the same now that you've moved on to RStudio, and like, what helped you? What was it about that situation that helped you be able to put out so many packages or books?
So I think it, like, for me, it's good when I find code frustrating because I am empowered to be able to fix that frustration. I'd say probably the biggest reason that I'm much more productive at RStudio is that there's now no longer a lot of frustration in my life that I am not empowered to fix. And some of that, I think, some of that, I think I made bad decisions, early on in my time at Rice that made things worse. Some of it was kind of endemic to Rice. But I think one thing that I have really learned at RStudio and learned by, watching JJ and Tarif, the CEO and president, is that there's actually often like doing the wrong thing is worse than doing nothing at all. And particularly like working with the wrong person makes you less productive than working with no one at all. And I think, like, when you join a university in particular, like, there's a lot of, people are excited that there's someone new to work with, and they want you to be on their committee, and they want you to, help them with this and that. And it's always really nice to help people because you get this like immediate feedback. But it's also very easy to like spread yourself too thin where you end up like you've just got so many conflicting responsibilities and you don't have that like deep time to focus on one problem until you really nail it. So I think like that, I think really the thing that makes me productive is focus. Like when I can focus on one thing or just a handful of things at a time, that's what makes me productive. And I've kind of like organized my life to make that possible. So, part of that's only possible because of my job at RStudio, but basically like when I'm working on something, there is no way you can get in touch with me. Like I don't really respond to emails regularly. I ignore IMs. I won't pick up the phone if you call. Like, you know, if you come and like physically knock on my door, I'll probably do something, but that's about it. And so I think that's really, really useful. Like having that time when no one can interrupt you. You know, then I think the challenge is making sure you don't interrupt yourself. And that's, you know, also a constant struggle. But I think, I don't know. I mean, one thing, and I don't know what I've done to achieve this, but certainly now I feel like I can concentrate pretty fully on a problem for hours at a time. And when I'm really in the zone or in the flow, like hours can go by without me getting distracted by anything. And so I don't know exactly, like, I think that it's a really valuable skill to have, that ability to just focus on one thing and not distract yourself with other things. But I think that's a really, really valuable skill, but I have no idea how I actually developed that skill.
Any other questions? Mike?
I have a question. Today, of course, I'm taking a GIS course, and we're going over data ethics, and how like something like Google Earth can get enough data from yourself, or how like companies are able to extract data from you, like from your smartphone, and if it's ethical or not to get into your privacy without any consent. And I'm just wondering, what's your opinion on how far can we go for extracting data from a person?
Yeah, I come from a country, New Zealand, which has pretty strict privacy laws, and I don't know. I think that a lot of companies are doing like pretty creepy stuff, and I've kind of like deliberately started pulling myself off of Google products a little bit, just because I think what Google is doing is like getting to the point of being profoundly creepy. And they couldn't care less about me as a person. They just want to get all my data so they can sell ads based on it. And that is something that, you know, I feel like that's something that's pretty appealing about Apple to me. About they go through, like they go to a pretty extreme extent to make sure that even Apple doesn't have personally identifiable information about you. And one thing, I can't remember the exact details, but even like when you search for directions on Apple Maps, it like breaks it up into kind of two halves and submits them in such a way that there's no way to link them together, as like a way of, you know, even if someone comes to Apple and says, you know, give us this data, the Apple can't do that. And and that, you know, they make money not by selling my information to other people, but by creating things that I want to spend money on. So I don't know, and that's, I mean, part of that now though is if like I'm in this sort of fairly privileged position economically where I can basically buy whatever Apple product I want and not care about it. And you know, I care about my privacy much more than I care about, you know, money effectively. So I don't know. It's sort of one of these things where I think this is sort of an area where I think legislation is important, because it's very easy for people to do things that are not actually in their own best interests. And I think one of those things that's not generally in people's best interests is giving away your data for free or in return for like a free service. And I don't know. I just kind of find it distasteful, like how companies try and collect every single bit of information about you so they can sell it on. And, you know, those are companies I generally try and avoid.
Well, this question is more about performance and machine learning. So in the problems that are not necessarily big data and where you don't have to scale it, how is performance really an issue right now? And like, will, for example, a new language like Julia, which is really fast, will it eventually become very
That's a harder question for me to answer just because I don't know that much about machine learning. My sense is though that, I don't know, like I think there's definitely different types of people when it comes to programming languages. And the programming languages I have spent the most time on VBA, Visual Basic Applications, PHP, R, and C++. And those languages are widely considered to be like the worst languages ever. Like they're just disgusting and awful, and clearly the people that created them were so brain dead they didn't know what they were doing. But they all allow you to get stuff done. And I think the thing that appeals to me least about Julia is that it's like this sort of like beautiful, pure theoretical construct. Like it's perfect and everything's correct and lovely. And so just kind of as a, I don't know, I'd like my programming language is a little dirtier, I guess. I mean, another kind of thing I think is like I don't know whether this is true or not, but like my take on it is like every programming language or even like every programming language has either made a terrible design decision or will make a terrible design decision. And if you stick with languages that have already made a terrible design decision, people already know how to work around those problems. Whereas if you pick a new language whose mistakes have yet to be made, you might be the one who has to figure out how to work around those hideous problems. So I think I think if you want to write performance machine learning algorithms at a low level today, you should just suck it up and learn C++, because it is blazing fast, and there is everything you could ever imagine has already been done for it. Whereas Julia, like, it's exciting and new, and sort of it's kind of like you can't entirely compete with a fantasy, right, or with your imagination, because it hasn't been made concrete yet. So the reality of like Julia is going to be worse than the imagination of Julia. And I don't know. So I just feel like you can do so much in C++. C++ is much like R or much like JavaScript. Like to write good code in those languages, it's as much about what you don't do or what you shouldn't do as what you can do. And so I think like modern languages like Julia and Rust and Go, and the kind of goal of those languages is to make it so you can't do the things you shouldn't do. Whereas with R and C++ and JavaScript, you have to learn what you shouldn't do and then not do it. You have to like deliberately make that choice to not do it. And like it absolutely does add like more cognitive overhead. You have to like think more carefully about things, and there are whole classes of mistakes that you can make that you can't make in stricter languages. But everyone knows what the mistakes are, and everyone knows how to handle them. So to me, that's quite appealing. And just, I mean, I think the other thing generally is like, you can never evaluate a technology in isolation. You have to evaluate kind of the ecosystem. Like, does the ecosystem make you more productive? And if the Julia ecosystem makes you more productive because there are more people like you working on the problems you're interested in, like, absolutely do it. Like, pick Julia for that reason, because there are people like you using it, rather than because, of some attribute of the language.
Cool. So I had a few background questions from the students in the workshop, and one of our goals is to equip students with enough of the statistical skills, and as well as the programming skills in order to start to provide immediate contributions to a workplace that they join as a data analyst. So the route we've taken is with R and trying to integrate integrate database programming as much as we can. But from your perspective, what do you look for example, when you're interviewing somebody as a data analyst, or what would you look for in a person that you're interviewing as a data analyst?
Yeah, I don't know if I'm the right person to ask, because I don't think I'd ever actually hire a data analyst, and these days I barely do any data analysis myself. But I think that like one of the key things to being an effective data analyst is this, like this, you have to have some model of data, and my model is tidy data, which I think is pretty good. But regardless of whether you subscribe to that philosophy of working with data or another philosophy, you need to have like some coherent philosophy for how you structure your data. Because if you have that coherent way, then you, like, different problems that seem radically different at first often turn out to be just different kind of instances of the same more general problem. So like if you have some framework, you have some way of consistently storing your data, then you could learn the tools that work with data in that format. Because I think that's really important. So you just kind of don't like churn your wheels going nowhere, just trying to cram the output of one function to the input of another function. I think the other thing that is important is I think you need to have some strategy for improving your knowledge of the domain. Like what do you do every day or every week to make sure that you're a better data analyst than you were the week before? And maybe that's just Twitter and like following up from things on Twitter. Maybe that's you have like a reading list of books you work through. I don't think it really matters exactly what it is, but I think you should have some strategy for improving yourself. Because if you don't, it's one of these things that's really important, but it's never urgent. So if you don't have like a strategy, if you don't like deliberately make sure that's high up your priority list, it's very easy for that just to keep getting pushed back and back and back. And I think that like generally things that you invest in that pay off like with interest is really valuable. And like learning, how to become a better R programmer, learning how to learn better, like stuff like that. Like as you get better at it, you get better at lots of other things. So I think that is also really important, like having a deliberate strategy for self-improvement.
I think that the second question kind of relates to that is there was a question on Quora that was posted that how the heck does Hadley pump out all these packages at this rate? Like, does he have people working for him? Is he outsourcing his work? So people were just, like, I'm still confused as to how you're able to, I think you answered part of it, but how you're able to push out these packages at such a high frequency, but the quality of them are still very good.
Yeah, I mean, it's hard. I can. If you ask me how to make a good package, I can tell you because I've made lots of them. But I can't really answer the question of how do you become a productive human being because I only have like a single data point. So I kind of, like I'm not sure. Like I even subscribe to the belief that you should ask experts what makes them productive, because it's not clear to me that taking their advice is actually helpful in general. Like there's just, I don't have enough. I mean, I'll tell you the things that I do that make me productive, but I have no evidence to tell you whether or not they'll make you productive. I mean, I think the meta point is you need to figure out how you can become as productive as possible. I think one of the things that has like helped me is that I am a very fast reader, and I have been a very fast reader for a long time. So I'm not saying this. I'm not saying like you should go out and learn how to read faster. I don't think that'll help you. But I'm saying like, so the fact that I can read very quickly, like that means that the best way for me to ingest new information is to read about it. And I think I'm also like quite good, and I don't know why this is the case, about when I've read something, like I don't feel like I necessarily like I have to consciously remember it to get some benefit out of it. And so somehow like, so what helps me is like, you know, I read very widely. I think my reading comprehension is probably like well below average. If you were to like, if I read a book and then you were to ask me questions about it, I'm sure I would do absolutely terrible at answering any specific questions. But somehow often like the main theme kind of sticks. And the other thing I think that's really valuable and like that's helped me is like, you know, I like words and I like knowing the names for things. And like when I was a kid, that's mostly kind of, you know, the fact that I know like the plastic tips on the end of shoelaces are called aglets, right? Like that's a fact that basically serves no purpose, right? Unless you want to like impress people with your knowledge of shoe part names. But knowing the names of things in general is actually really useful, like and knowing the names of problems or like of algorithms of general things. Like once you get the name of something, you can then just Google it and find out the rest of it. But so again, like that's something that's like helped me because I've always been interested in words, and that's sort of like one of the like the keys that I think is sort of unlocked further value. I mean, if you need to find like what that is for you, like I don't think you can't like force an interest in words. Either you're interested in them or not. And I can give you, if you are interested in words and knowing the names of things, I can say I think that's like super valuable. And you know, read widely, and then when you encounter new problems, hopefully a little light bulb will go off and say, oh, hey, I like vaguely remember reading about this and it was called X, and that's really helpful. I think you kind of need to figure out, like for you, what are the things that you are currently good at and enjoy, and how can you kind of like key that into things that make you productive. And I can only offer, you know, anecdotes based on what's worked for me.
I guess a better question might be when, for example, before dplyr or before dplyr, what was your sort of problem-solving framework to address this gap, and then to actually go out and create something that solved it? Like, what was your I guess thought process or problem-solving process in seeing a gap and then?
Yeah, I don't know. It's sort of hard too, because I think one of the hardest things about these tools is kind of like I think like my definition of a good tool is that in like hindsight it should seem obvious. So like now when I look at the functions in dplyr, like, you know, it's like filter, arrange, mutate, summarize, and select. I kind of like look at those and I'm like why did it take me like 10 years of programming with R to realize that those are like 5 really useful things you do to data frames all the time? And certainly like some of them, like there's, you know, there's base equivalents for like, you know, there's transform and subset, which is similar to mutate and filter. But I don't know, like, so somehow it's kind of like progressive that you like my kind of rule of thumb is until I've like completely like worked a problem up from scratch from like, it was like 6 times, I don't really understand it. So like the sort of rule of thumb is like anything that I'm particularly proud of, there's been at least like 6 often completely different attempts to solve that problem. And you know, like dplyr was an evolution of plyr, which is an evolution of reshape. Like each time you kind of get a little bit further and you realize, oh, I've solved this, now that I've solved this problem really well, I realize actually that isn't the problem that needs to be solved. Like I think dplyr, now I look at plyr and I think that does like a fantastic job of solving a whole lot of problems that people never have. But it takes a while before you because until the tool exists, you can't tell whether it's going to be useful or not. So I mean, I would kind of say, it takes a long time. And, one of the things that I think the two of the kind of unsurprising things that make me very productive are that I've now been doing this for a long time. Now I've been working in this domain for like 10 or 12 years now, spending a significant amount of my time on it. And the other thing is now I am in a job where basically this is all I do for 8 to 10 hours a day. And I think like many people, like if you have like 10 years of experience of doing things for 8 hours a day, you get really productive at it. And I think one of the reasons that I am particularly productive compared to most R programmers is because that's all I do. Most R programmers, most people programming in R have some other like goal than not just to get better at programming R. Like they're trying to do something. They're trying to solve a pressing problem. And then again, they just kind of like focus on one problem for a long time really helps. And it takes me a long time to kind of gather up like sort of related problems or problems that seem related, and sort of slowly over time they kind of like percolate, and I start to see like the shape that underlies them all. And that's sort of something that's happening to me at the moment with the Purr package, which I still don't know how to describe in a way that conveys how incredibly useful I think it will be when it's finished. But basically it sort of imports a whole lot of functional programming tools from other programming languages and translates them into a way that works naturally in R. And that is like a terribly unappealing sell, because like if you don't know what functional programming is, like why the heck should you care? So I think it's sort of maybe another way of thinking about it is like Purr is to lists what dplyr is to data frames. And it took me a long time to figure out what the right verbs for data frames are, and it's now that's sort of slowly coming together in my head what the right verbs for lists are. And then once you have those verbs, then you can do a lot of interesting things. Now, one thing that's interesting about Purr that I just sort of realized today is that Purr is not only going to provide verbs, but it's also going to provide adverbs. In the sense that it's going to have functions that modify how other functions work. And that's, I don't know, that sort of seems like to me that's like a fairly profound insight, that you don't just want verbs, but you also want adverbs. Now, I mean, maybe the next logical thing is I'll think, well, maybe we also need adjectives, and you already have nouns, I think. But like, so that's also sort of part of the way I think, is like how, when I think about these problems, like what are related things that might offer interesting tools. And English language is obviously provides tools for expressing ideas, and thinking about how those map to programming languages is, I think, also pretty interesting. And then that ties back to my interest in words and language and reading.
Awesome. I think this also relates to what you're talking about these packages you're working on. With our studio, it has a few products like Shiny, the Server Pro. So, I mean, I don't know if I could speak to it exactly, but do you have an idea of maybe what the goal of our studio as a company is in terms of its products?
So I think about our products doing kind of two things. And the first thing I should say, like the goal of the commercial products of our studio is to find like the smallest possible subset of features that big companies will pay a lot of money for. And that's how we make our money, by finding those small things that people with lots of money care about, and people that don't have much money don't care about. And I kind of find that appealing it kind of makes sense as a business model, right? Like you want to go after the people who have lots and lots of money. But I kind of find it appealing to me. Like we're about kind of, well, we're stealing from the rich and giving to the poor in some sense. So I kind of like, the goal is to try to make, in some ways, like as little money as possible to be successful. And I think the ways we do that currently that are particularly valuable for companies are helping kind of solve the last mile of data analysis. So that is like, as a data analyst, you have done the analysis on your computer. Now you need to get it to the decision maker in your organization. And the thing you produce, that might be an R Markdown report, that might be a Shiny app, it might be a plot, whatever. We want to make that as easy as possible to get that to the right people in your organization. And then, as a sort of a corollary of that, often you don't just do that once, but you want to do that so that, like, the managers of Group X every Monday morning get a status report about what they care about. And so I think like that broadly is one area where RStudio products help. So Shiny Server Pro helps that. We have a new product coming called RStudio Connect. And basically the vision of that is anything that you've got on your local RStudio desktop, you can publish to the right people in your company who know nothing about R and care even less about it. So that's one problem. I think of that like the last mile problem, getting you the results and the people who use them. And the other problem, I think, is kind of broadly like, how do you help large teams of people program, work effectively with R? And some of that is just like aligning with all of these things that big companies' IT departments want, with like authentication and logging and monitoring and all this other kind of like really boring IT stuff. And then some of that is also how, when you've got like, I think we're now starting to see companies that have like, there's a decent number of companies that have like 20 or 30 or 50 people working together programming in R, and then thinking about how can we make those people as effective as possible? How can we make big teams effective? I think we're still only kind of scratching the surface of that, but one thing that I think is really cool in the next version of RStudio Server Pro is collaborative editing. So multiple people can be editing the same file at the same time. So if you want to like work collaboratively with someone on the same file, that's really useful. And then sort of along those same lines is being able to have different projects that run different versions of R. Because as soon as you've got lots of people working on the same server, they're going to have different requirements for packages. They're going to have different requirements for what version of R you need, and how can you kind of make all those people work seamlessly together on one shared resource.
Perfect. And Judith,
There's something I've been wondering, like, I think you started at RStudio a couple of years ago, like 2 years or something like that, going free. Like, what do you think over that period of time have been the most interesting things that you found working at RStudio?
I don't know. I mean, from my perspective, the best thing about working at RStudio is there is just like so, like you kind of expect when you do any, like my expectation was that like every job has a certain percentage of time where you have to do stuff that sucks. Like there's just sort of boring administration stuff. There's just things you have to do, not because they're particularly important, but because you just have to do them. And my expectation was that's like, I don't know, 10 or 20% of your time is just sucked up with stuff like that. Things you're not particularly passionate about, but you have to do. And the best thing about working at RStudio is basically there's nothing. There's like no demands on my time apart from the demands I put on myself. Which is kind of good and bad, but the bad side is when I screw up and I'm not effective, the only person I have to blame is me. But it is the nice side is that I'm completely empowered to make any decisions I want to about the way that I work. And if I wanted to like go dark for 6 months and basically not talk to anyone, not do any public speaking, not work any books, not answer any emails, like I could do that. That's just the choice. That's up to me. If I want to just like devote my time to one thing and ignore everything else I've done and not do any bug fixes, like RStudio would be absolutely 100% fine with that. And that is like really incredibly valuable. And the other thing is part of it, compared to going from a job which was tenure track, where basically my impression of the management process was to make sure that I felt uncertain about whether I'd get tenure or not, so that I would work harder, which, let me tell you, is an absolutely appallingly bad management strategy, to a place where like I am like absolutely respected for who I am and what I do. Just like the amount of time I've spent like stressing about work has gone down to nothing. And I have I try getting pretty close, but I never work past 6 p.m. at night. I never work on the weekends. Like I have a really good work-life balance now, and that has just like made me a lot happier as a human being, and that makes me more productive too.
Any other questions? If there's nothing else. Thank you so much for coming out and talking to us. It's a beautiful day here in Vancouver. It's pouring rain, so I think that might have affected some of the turnout today. But thank you for coming out, and hopefully look forward to seeing you sometime soon.
You're very welcome. Thanks for having me.
Perfect. Thank you.
Bye.